Okay, so for example 1, we'll do something like this. They'll ask 1 an element of, and then they'll give you some braces off to the side to kind of show you that this is the part that they're talking about. So basically, they're going to ask you something like this: Is 1 an element of this set of numbers over here? And again, you're either going to answer true or false. In this case, 1 is not a part of this, so then the answer, of course, would just be false. And then they'll do, all right, is 6 not an element of 3, 5, 7, 9, 11? And in that case, 6 is not an element of this one, so in that part, that would be true. Okay, and then one of the other problems that they may give to you when you're going through these is just asking if 2 different sets are equal. In order doesn't matter when it comes down to sets. So like this one, if you have A, B, C, D for this set, and this one's D, C, B, A, as long as all the elements are the same, the order doesn't matter. So in that case, that one would be true. Okay, so there's just some examples of what they'll do to get you used to the different terminology that they use with sets. They'll throw some different questions at you, but I think once you play around with them and you go through them at least once or two times, you can usually pick up on it pretty well. After they go through that one, then they start adding in a little bit of some more vocabulary. The next one they're going to do is a subset. And the notation for that one is like a sideways U with a bar underneath it. And basically, for a subset, that just means that all the elements of one set are part of a larger set. All right, and just so you kind of get some examples here, let's say that set A is 1, 2, 3, and set B is 0, 1, 2, 3, 4, 5. And just for notation wise on this one, they may give you something like this, that A is a subset of B. And they can also use the slash through this one. So if you flip this thing around, you would say that B is not a subset of A, because not everything in B is in A. So just like when they used the notation here, back up here earlier, when you put the slash through it, same thing for putting the slash through it, that if you put the slash through that, that means it's not a subset. Okay, and then one little trick question that they will throw at you on this one. If you have an empty set, an empty set is a subset of any set. So I thought that was, I was going through one of these, and that was one that kind of jumped out at me as like a trick question when I was checking out some different things. So if you see anything about an empty set, just realize that an empty set, even though there's nothing in it, it's still a subset of any set that's there. Okay, and then after that, they start giving you, still dealing with subsets. They start figuring out how many different groups you can put in the subset. And that one's got one easy little formula for this one. We'll just say it this way: the number of sets well, hang on. Where did that? Hold on. Didn't say the right thing there. Let me try that again. The number of subsets went backwards there. So the number of subsets of a set with n elements is 2 to the n power. Okay, so they'll ask you kind of the same thing with this one. Using that formula, they'll give you some different sets, and they'll ask you, okay, how many subsets could you get from a problem like this? Okay, so if you have a set that's got 4 numbers in it, doesn't matter if it's 1, 2, 3, 4, or A, B, C, D, or orange, blue, red, green, whatever it is, if you've got 4 elements in that subset, then it's just going to be 2 to the 4th power. 2 times 2 is 4, 4 times 2 is 8, 8 times 2 means that the total subsets there would be 16. Okay, and really about the only tricky thing I could find on this one for the different problems that they gave to you would be some of the word problems that they kind of mix in with this one. So this may be that it's the integers between 3 and 10 is your subset. And they should tell you that if they're talking about between 3 and 10, they don't really mean that you're counting. Leave 3 and 10 out. It's almost what they're saying. So really for this one, that means that would be 4, 5, 6, 7, 8, 9. So you've got 1, 2, 3, 4, 5, 6 elements. So that means you've got to do 2 to the 6th power. So if 16 was 2 to the 4th, times 2 is 32, times another 2 means that there would be 64 subsets you could do with that one. Okay, so one easy little formula when you're finding out the number of subsets is just 2 to the n power, where n is the number of elements that you're looking for. Okay, and once they go through that one of the other terms that they're going to talk about is complement. And when they talk about complements in this case, complement is basically everything that is not in the set. And the notation that they're going to give you for that one is basically they call it a prime. So if you were talking about set A, then the complement would be A, and they put a little tick mark at the top, so it's A prime. So whenever you see the prime part of it, that's what the notation is going to be for complement. Okay, so whatever set they give to you, the complement will be basically just taking whatever number, whatever letter they have for that set, and just put the little tick mark at the top of it to make that the complement. Okay, so easiest way I can think of is that if A is equal to the odd numbers, then the complement of A then be all the even numbers. Or you could go vice versa. If A was even numbers, then the complement of A would be the odd numbers. So they go back and forth on those two. The other two things that we're going to talk about that they can kind of mix in with those is where if they give you a, and this would be between two different sets, they'll give you a U or an upside down U. The upside down U is what they call intersection. And the intersection is where you find out what they have in common. So when they talk about the intersection, it's what both sets are going to have. When you talk about the union is basically taking both sets, putting together, and making one big giant set. So this is any element that's in either set. Okay, so complement is the prime little symbol to it there. Intersection means it's just what they have in common, what both sets have. And then the U is where you take the two sets and combine it together and list out any element that's in either set. So it's just anything that shows up in either one there. All right, so what we're going to do is let's give you just some sets here. So let's say that set C is numbers from 1 through 7. And they may tell you that A is 1, 3, 5, 7, and that B is 3, 4, 6. Okay, so basically what we're saying for this one is a set C tells us this is all the numbers we're going to use: 1, 2, 3, 4, 5, 6, 7. And then A is a subset of C, and then B is also a subset of C. So they may go back and do something like this just to let you know that we're talking about subsets, that basically 1 through 7 is the full range of numbers that we're using for this one. And then A is just the numbers 1, 3, 5, 7. And then B is just the numbers 3, 4, 6. Okay, and with that, they're going to ask you just all kinds of different questions on this one using intersection and complements and unions and just throwing all kinds of different things at you. So probably one of the first things they'll do is they'll say, okay, what is A prime then? So if you take out 1, 3, 5, and 7 out of this group, tell me everything that's not 1, 3, 5, 7. Well, that would be 2, 4, 6. Probably ask you for B prime. So if B is 3, 4, 6, B prime would be 1, 2, 5, and 7. Okay, and then we'll do A intersection B. Okay, and again, intersection is just what they have in common. So then you go back to A and B. In this case, all they have in common would be 3. So it would just be that one number that would be there. Where on the flip side, if it asks us for A union B, that's where you just go through and start listing every single number. And if you list those, you don't necessarily have to list them in order, but a lot of times, especially if it's a small set of numbers, they may do that. But it should take the answer either way. We've got 1, 3, 4, 5, 6, and then 7. And again, order shouldn't matter.
Sorry, I have just a quick question.
Go ahead.
Double checking, we don't list the 3 twice when you have a union between the two.
That's correct. Yeah, if it shows up twice, you do not have to list it twice. One time is plenty. Okay. Yeah, if y'all have a question anytime, just pop in and let me know. Sometimes I'll see the hand up and sometimes I don't. But yeah, if you've got a question, just pop in and that'll be okay. So good question. Okay, a couple more of those. Let's do the primes on this one. Let's do A prime with an intersection of B prime. Okay, so we're back to these lists now, back to the problems we had back up here in the beginning. So we're trying to figure out what they have in common here. And for these two, the only common part that you have would be 2. All right, and they may also mix it up, so it may be that you may get like A prime, and we're going to put a union where that would just be. So A prime, we have 2, 4, 6. With B, we've got 3, 4, 6. So A prime, and again, the order doesn't really matter, so you know you're going to have 2, 4, 6. Oops, sorry, start too quick there. And then when you go to B, tell me anything that's not 2, 4, 6. Well, 4, 6 repeated, so then we had 3. I'm going to put that at 10 here. So then it would be 2, 4, 6, and 3. Okay, and again, order doesn't really matter. If you want to do the order and if you want to turn it around and put 2, 3, 4, 6, that would be fine. But as long as you've got all the numbers listed, that's really all you have to do. Hey, there we go. All right, found my zoom option. That'll make things a little better. Okay, that'll make things a lot better. All right, I'm going to try to see. I think there was one more problem from section 1 that yeah, here we go. And this was one that I found that was it was kind of hard to. Well, let me just go ahead and give it to you this way. Because there was one problem in the homework that went through that was, I wanted to share it with you because it was a little bit longer or a little bit different than some of the other problems. Okay, so we'll give everybody a second to kind of write that part down. Oh, sorry, you can't see the bottom part. Pull it up a little bit more. There we go. Okay, so X is VW, and it's a smaller X. 789. Y is WYZ 7911. And then set Z is WY and then 8911. Okay, and then they ask you for, it's a compound statement basically. We've got X union with the intersection of Y and Z. So anytime they give you a problem like that, where you've got a set of parentheses, you can basically block off the first part of it and then key in on just the part that's here. So we're going to do the intersection of Y and Z. So this is where you go back in and tell me everything they have in common that's here. So they have a W in common. They have a Y in common. They have a 9 and an 11. Okay, so it's basically just like your regular order of operations where you have a set of parentheses. You have to do that first. And now you're going to go back and do this where we're going to do set X. We're going to put that together with basically W, Y, 9 and 11. Okay, so set X, basically just go through one time. We've got the V. They both have the W. This one has a Y, that one has an X, so I need both of those. This one has 9, 11, that one had 7, 8, 9. And then 11 would put us there. Okay, and then that would be the final answer they were looking for. Okay, so it's basically just a problem inside another problem, where if you have a set of parentheses, you've got to do that part of it first, and then when they give you that other set, then you take that set and compare it to that set, whether you're either finding the union or the intersection, to walk through on that one. Okay, and I think from 8.1, that's pretty much everything that they're going to throw at you. So it's a wide range from just the basics on sets to complements to unions to intersections, just to everything all over the board. They'll give you some different options, different sets, and have you work through those. But it's say most of the time, if you just sit there and even if you get stuck on a problem, just let me know. We can walk you through that one. Usually, it may just be one little thing that may be throwing you off, but I think most of those are pretty straightforward once you kind of get through the basics on it. All right, before we move into 8.2, any questions on anything so far? Okay, so 8.2. Still dealing with sets, but really 8.2 makes a big move to Venn diagrams. And one of the very first things they do, and we'll kind of go through this one, is actually one that I don't think is quite a Venn diagram problem, but they kind of say that it is. And we'll talk about everything that's with Venn diagrams here in a minute. But I think one of the first problems is they go through and tell you one of the first problems in the homework says, if we can kind of do this, says there was 100 top grossing movies. And again, it's a big word problem. So you have to kind of go through the word problem and just figure out what all it's asking for. It said that there were 11 PG-13 movies that made more than $100 million. And it said there were 40 PG-13 movies that made less than 100 million. And it said there were 31 that were not PG-13 that made, and again, that could either be R or G or whatever they wanted to put in for that one, PG. But then there were 31 that were not PG-13 that made less than 100 million. And then the question was, they said, what was the number of movies made over 100 million that were not PG-13? And when I read the question, I thought, well, it's basically saying movies that are either PG-13 or not PG-13. So we had 51 back here that were PG-13. We had 31 that were not, that made less than 100 million. So I thought, well, this is not even a Venn diagram problem. This is just a total. You've got 100 movies. If you add all these together, because they're all in different groups, this one's PG-13, $100 million or more, PG-13 less than 100 million, and then this was a not PG-13. I added all these up, and I was like, well, that's 82 movies. They made 100 movies. We've taken care of 82, so then we just subtracted those two, and that came out to be 18 movies. They try to make it a Venn diagram problem, and it's really not a Venn diagram problem. Because and I guess they were setting it up to each one of these movies. I guess they would have done it this way. They would have said there would have been 100 things here, and each one of these movies would have been in like a separate category. It's like, well, if that's the case, you don't need a Venn diagram for that one. That's just here's the different categories. Here's what we're doing. Kind of run through the numbers, that kind of thing. So it was, to me, that was one of those. It was, yeah, you could do a Venn diagram, but you really don't need to do a Venn diagram because you can just do it a lot easier just by figuring out that it's just a total amount that they're going for, and here's the numbers that they give to you. So that to me was a question that wasn't really a little bit misleading because you did not have to do a Venn diagram. Okay, so here's where you want to go back if you haven't already, and I'll put this on the projection here. Here's where you want to have examples that's on the course content on the left side of Blackboard there. If you look under course content, there should be like 8.2 examples that you can pull up, because this is one of those questions that with all the examples in the book, everything in the homework, there really wasn't a good way to do this other than just printing this out, because I don't know how else to do it. I mean, this is one where they say use a Venn diagram to answer all these questions that's here, and this is one you have to use a Venn diagram. There's not really any other way to do this one. Okay, so basically, here's what we have. It tells you that there are, and for this particular problem, this is one we're looking at. We'll look at a different one here in a minute. It's got different criteria on it, but see if I can zoom this in a little bit more. Okay, so we've got a human resources director. They're a real estate company, and these are people that are applying for a job. And it gives us the questions here at the end that we're going to answer. But basically, and again, if you want to pull this up, probably be easier to look at on your paper, and we'll go back and answer these. It says you've got basically got three categories. You have 37 people with a college degree. You've got 61 people with sales experience, and then 25 people with a real estate license. And then they tell you, okay, here's all the people that have some combination of those, whether they've got two of this or two of that or two of something else, or maybe how many people have all three. And then at the very end, they also say that there's 28 that don't have anything. So that's another category that's here that you could kind of put in with that one. So you've got these three groups of people, and then you've got the people that don't fit in that group at all. And that's kind of what you're looking at. Okay, so here's where we're going to go back and kind of put all this together. Here's where you would have to do your Venn diagram on these. Okay, so there's our big box of people that we have. This is all the applicants that's in the group. And you've got three main categories that you have here. Okay, so you'll start off with something like this, where you can say this is, I would put an E up here for experience. This would be a D for degree, and then this would be L for their license. So that's the three different categories. And then everybody outside that, that's the 28 people that don't have anything. So you can go ahead and put that out here, that there's 28 people out here that don't have anything at all. So now we've kind of taken that one. It's almost like you just go through a checklist and check off each one of these that you have. And the easiest way to start on this one is to start with this one little spot that's in the middle that's got all three. That's kind of the key where you want to start with this one. And we look up here and we have 11 people that have experience, a degree, and a real estate license. So that's what goes in the middle right there. Okay. And then from there, you can start kind of going one group at a time. If you look above that one, let's see, we've got 17 people with a degree and a real estate license. So if you kind of go back and start keying in on this one, if you take out the experience part, we've got to have 17 people that have a degree and a real estate license. So that's this group that's here, that's in common between the degree and the license part. There's 17 total here, but you already know that there's 11 that's got all three. So if we basically would do 17 minus 11, that'll give us 6 that would go here, because there's got to be 17 total between that group of two. Okay, so then we'll kind of cross that one out. And then we go back and do the same thing with the other two groups. Above that, we've got 13 people with sales experience and a license. So now we're over here with this group that we've got. We cover that up for a minute. We're looking for the overlap of these two circles. That's here. There's 13 people here total. But this group, it's hard to see there, already had 11. So that means that there's 2 people here. So these two things had to add up to be 13 with the 11 that was already there. And then you'll do it one more time with the experience and degree. So this is with the top 2 circles. So it says there were 23 people there that kind of fell into these 2 circles that were here. You already had 11 here, so if we do 23 minus 11, that would put you at 12 there. Okay, so every one of these Venn diagram problems that they give to you with the 3 different categories, you'll basically do that. You'll start in the middle with what's all 3 have in common. And then you'll break out to figure out, okay, they should tell you that, if you've got a degree and a license, there's so many people that's here. Well, if you know what they have in common, then you can kind of go from that part and just subtract that amount, and then do that for each one of the different categories. Okay, and then what you can do from there is now you can kind of go back to the questions you had in the beginning, because it said back here in the beginning that if we look at just the E part, if we can cover everything else up except for the E, which was here, it was that circle. It said there was a total of 61 people. There were 61 people that had experience. So you can almost put a 61 by the E there. Well, if there was 61 people that had the experience, we've got the 12, the 11, and the 2 that had all those things in common. So just add up these 3 parts right here that's the overlaps with the other circles. So that's 23, 24, 25. Take out those 25 people that had overlaps with other things. That's going to tell you now that there's 36 people that had just experience without anything else. and then you'll go back and do the same thing for the other parts. If you wanted to figure out the degree part, we cover up everything except for that circle that's here. And for the degree, it said that there were 37 people that had a degree. Well, we found all the overlaps here. So we've got 23 and 6 is 29 people. So if we take out the 29 people that had something in common with the other groups, that's going to leave you with 8 people that had just a degree. And then we do the same thing with the license. There were 25 people that had a license. You cover up everything outside of that circle. So you had 11, 6, and 2. Altogether, that's what? So that's 19 people. Take out those 19 people that had something in common with the other groups, and that's going to leave you with 6 people that had just a license that was there. Okay, so every Venn diagram problem they give to you with the 3 groups, it's always going to be that same setup. You'll start with what they all 3 have in common, and then from there you just keep working your way back out to figure out what it is that they have and kind of go from there. Okay, so the very first question says, how many applicants were there? And this is one where that now that you've got all these different little groups, you basically just go back through and add up all the different little groups that's here. You've got now, and there's a couple of different ways you can do it. That some people would see that, okay, if we know that the experience group was 61 that's in that circle, we know if we add these numbers together, that's going to come up to be 61. So you're taking that part out. And that's kind of what I like to do is find one of the groups, doesn't matter. Sometimes it's the biggest group. Figure out what's in that one big group that's here, which we know was 61. Take that circle out, and that way you've only got a few more numbers left over. So once you take out the circle number that added up to 61 here, we had 8 that had just a degree, 6 that had some here, 6 that were just a license, and there was 28 people that didn't have anything at all. So then we put them over there, and then you just add all that up. Again, the other way you can do it is just go back and add each section, 36 plus 12 plus 8 plus 6 plus 11 plus 2 plus 6 plus that one. So you can do each little individual piece and put it all together. But one way you can kind of sneak around that one again a little bit is just to take the biggest group that was by itself. You already know that they gave you the total back up here, which was 61. So you know that everything in that circle has to be 61, and then just add up the other pieces for everything that's here. If you add all that together, let's see what we get here. That's all 3 of those together is 20. So that's 61, 20, 20. That's 9. Looks like that's going to be 109. Okay, so that would be part A. Part B, again, it's hard to read on that one, so hopefully you can pull up that copy. Part B says, how many applicants did not have sales experience? So if you had 109 total, so there were 61 that had sales experience. So take out the people that had the experience, so that would leave you with 48. So once you've got the total for that kind of question, it gets pretty easy. So for part B, that one was 48. C, here's where you have to kind of start comparing a little bit. It said, how many had sales experience and a college degree, but not a real estate license? So in that case, they want just the experience and just the degree part. So basically, you're taking out the triangle. And they're saying, all right, how many had just experience and just a degree, but didn't have their license? So that's basically the overlap of the two. That's the intersection of the two that's there. So that part would be 12. And the D part, first time I read this one, it kind of threw me off a little bit. Because it said how many people have only a real estate license. Well, I thought it was like, my first thought was the 25 that was back here. I put it in and the answer was wrong. And I had to read the question again. It's like, oh, okay, so this one is saying, all right, of the 25 that's here, how many don't have anything else other than just the license that's here? So in that case, that one would be 6. Okay. Because I didn't know. I almost read it as like that was a continuation of problem C, but that was just a totally separate question there. Okay, so that was a lot of it there. And again, hopefully having this already kind of printed out and ready to go, that will make that a lot easier. If you had to write all that down, it would have taken forever to go through this thing. All right. If you want to take a quick time out, my mouth is getting dry. I don't have any water. So you want to take like a 2-minute break. I'm going to go grab some water and I'll be right back. Okay. All right. We'll do another Venn diagram here. Any questions before we get on to the next one? Okay. All right. So on the next page, number 3, it's got another big long problem that you have to go through on this one. This one's talking about blood types. We'll come back to that one here in a little bit, but basically same type thing that you got A, B, and then you've got the RH that mixes in with the A and the B, and then just all the different things can go from that one. So we're going through this one. There's the A, there's the B, and then the RH. Okay, and if you read through this one, basically the same thing. The part that has the A, the B, and the RH right in the middle here, there are 5 people. Okay, so you would go through and knock that one out. If you go to the next one, the A and the RH has 8 total. So if you look at the overlap of the A and the RH right here that you have, that one has 8 total. You've already got 5 here. So if you do 8 minus 5, that would leave you with 3 that would be there. Okay, they gave you 11 that was none, so that's 11 that's on the outside, doesn't have anything at all. So it's the part that's out here. It says there's 22 total with RH. We don't need that one yet. Come back to that one. The B and the RH, that's 11. So that would be the part that's over here. There's 11 that has both of these two in common. Well, if there's 5 that's already in the middle, we'll do 11 minus 5. So that'll make that part out to be 6. And then the last one up here with A and B, there's 7. So we do 7 minus the 5. That will make that one out to be 2. Okay, so again, start with what all 3 have in common in the middle. And then any part that's got the 2, you'll just basically take the 2 that's here and subtract that from what's in the middle. And then that'll give you the 3 parts for what you have there. Okay, and now it's just going back and pulling in the different parts of it here. If you look at just A, it says there was 18 total. Well, if you take everything outside the circle that's here and look at what's in the circle, there are 8, 9, 10. So we'll do 18 minus 10. That means there should be 8 that would be here. For B, there are 26. So look at what's in the circle there with 26. We've got 7, 6, 13. So do 26 minus 13. That means there'll be 13 here in B. And if the RH, there were 22. Okay, so 22 total. In your circle with the RH, you got 11, 3, that's 14. So do 22 minus 14, that'll be 8. And then you'll have 8 that would be there. Okay, and for this problem, this was one that it just kept going and going through some of the different samples of questions that you would see. This is one that just kept going and going and going and going and going on the answers on this one. So we'll just kind of go through and show you all of them here because these are the ones that you have to kind of read through the problem. This is where you have to go back to the actual word problem up here to read actually what's happening with it there. The very first one says, how many samples are represented? So again, I would start with the biggest group, which I think was B. So we know that B, there was 26 total that was here. And then take out that total of 26 that was there. And then just add in the rest of it. We had 8, 3, 11, and then, 8, 3, 8, and then the 11 that was outside here. So we had 26 that was in B. Then we've got 8, 3, 8, and then the 11 that was on the outside there. Okay, so that's 26, that's 11, 11, that's 22. So 11, 11, that's 22, plus the 8 that was here, so that's 30. So that's 26 plus 30. So that should be 56 total samples that were taken overall. Okay, so then it says how many had exactly one antigen. Okay, so that's your overlaps. That's taking out all the overlaps, everything that's in here. So anything that's got 2 or 3, you take all these out. And so this is all your 2s and 3s in here. So this would be, you had 13 that have just the B. You had 8 that were just an A. And then you had 8 that were just an RH. Add all those together, and that came out to be 29. Okay, so for the exactly 2, that's where you could almost go back here, even to list that was back here. We had 7 that were A and B, but you got the overlap here. So this is where, again, this is the 5 that's in the middle. This is where it has all 3. They want to know how many have only 2. Well, that's going to be the rest of the ones that are around this. That's going to be the 3 and the 2 and the 6 that's here. So 3 plus 2 is 5. 5 plus 6 means that's going to be 11. Okay, and most of these other questions back here, this is where you had to go back and read through everything that was back here. It says that the blood type is A positive if it has the A and the RH. So if you have the RH, that means it's positive. So for this one, and then it says the O that was back here, a person having only the RH antigen is O positive. So if you have just the RH and nothing else, then that would make it O positive. So in that case, that was this one that was just the RH by itself. So there was 8 people there. All right, part E said how many had AB positive? So that would be where you've got a mix of A and B, and you've got the H. So basically, you need all 3. You need the A and the B and the RH. So that's that part that's in the middle right there. So that would be 5. For F, how many had B negative? So in that case, it's B, and it doesn't have A, and it doesn't have the RH. So this is one where it's basically just B by itself. So that would be 13. If we go with O negative, let's see. So for the O negative, that's where we've got the RH. Go back to that one. So it says back here that if they have only the RH, it's O positive. If you have O negative, okay, so O negative means, so everything in here is some type of AB or O positive, basically. So everything here is AB something. This would be the part that's O positive. So basically, O negative means it doesn't really have any of this thing. So that would be the 11 that's here. That's the one that was, to me, the toughest one. I had to kind of read through that one and figure that one out. So if it's O negative, that means it's basically this group right here that doesn't have anything. It doesn't have the A, it doesn't have the B, and it doesn't have the RH. So you take all this stuff out and go from there. Okay, and then the last one that's A positive, so that's basically the A and the RH. So that would be this part that's right here. So that one should just be 3. Okay, so there's another one that's a Venn diagram. That one you have to kind of read through to figure out that, if you have the RH, that means it's going to be positive. If you don't have the RH, then that means it's going to be negative. And to me, that was the part that took me longer to kind of figure out the whole positive negative part on that one, but it's still tied in with drawing out a Venn diagram and just kind of realizing that it was still working the same way there. Okay. All right. So that was some of the homework from 2 and 3. Again, it's just different Venn diagrams. The key thing is they're going to give you 3 parts. Always start in the middle that's got the overlap of the 3 parts. And then once you've got all 3 parts that's here, then whenever they give you the part that's got 2 parts, you'll subtract that number from this to get this part. They give you the other thing that has 2 parts, subtract that number from 5, and then you just keep working out to get the other parts that's here. And then just keep working out to the edges as you get through those. Okay, so start you off with number 1 of the homework, really easy. 2 and 3, it's all Venn diagrams, just working with different, and then again, they may throw different options at you, but basically you'll have 3 different groups, and then you've got to start in the middle and then work your way out from those 3 different groups and go from there. All right, and then they're going to switch gears on you for just a little bit. We'll come back to the other problem here at the end. It's number 7. We'll come back to that one just a little bit. But then they're going to switch gears with you in a little bit. that they're going to talk about the counting rule. And with the counting rule, this is talking about with intersections and unions and different things. That they're going to start you off with basically this. The number that's in the intersection or the union of A and B, and N in this case, when they talk about the N here, that's the number of. That basically you're going to take ever how many elements you have in A, ever how many you have in B, just take the two elements individually here, and then you have to take out the overlap of those two, which is the intersection. All right, so let's give you some examples here to kind of show you the different options they'll do with you. So they'll keep coming back to this form and have you use it for 2, 3, 4 different questions. So they'll start off with something really straightforward. That you've got the number of A elements in group A is 8. The number in B is 10. And the number of the intersection is 7. And they want to ask you to find the number that's in the union. Okay, so basically we're going to plug into that formula, and we'll basically do the same thing here. So the number of A union B, that's what we're trying to find. So let's just call that X. The number of A was 8. The number of B was 10. The part they had in common was 7. So that's 18 minus 7. So that would put you at 11. Okay, so they give you the first one. Really easy. Just take the numbers, plug it in. They may give you, the intersection, or they may give you union. But either way that they go through this one, they'll give you one or the other, along with the different sets that you have here, and have you kind of work through and go from there. So they'll give you one that's really straightforward, really easy right off the bat. Okay, for the next one, same formula, same setup, but they'll just give you a different set here. This time they'll give you the number of A union B, and that'll be 27. They'll give you the number of A, which is 13, and they'll give you the number of A intersect B, which would be 7. And they're going to ask you to find the number of B. Okay, so we'll go back to the counting rule that they had back up here and just plug in the numbers and where they go. And we'll do the same thing here and start off with it. So for those, that'll be 27 equals 13 plus, and we don't know what that is. If you want to put a B here for B, you can do that. If you want to just stick with doing X, that's fine. And then minus the intersection, which was 7. All right, and if you want to, on the other side over here, just rearrange these terms so it's 13 minus 7 plus X. 13 minus 7 is 6. And subtract the 6 from both sides, so then that would come out to be 21, which would be your number of B. Okay, so there's a few problems where they'll give you, just different bits of information, give you an intersection, give you union. In this case, they ask for how many were in B, but they'll just give you some different parts and pieces and just basically just plug it into a formula and then working it out from there. Okay, and then where they're going to get a little sneaky. This is one where they kind of will make you use a Venn diagram to kind of get you there. Because this is one I tried to do this one without a Venn diagram and I couldn't do it without a Venn diagram. So we'll go back and make this one out to be a Venn diagram. So the number of A is 23. The number of B is 26. A intersect B is 17. And the number of B prime is 41. Okay, so for this one, and let's see what this one was here. Got one thing on it here. Hang on, let me check. This is where they give you a drawing after this one. And I'll tell you that this is set A, this is set B, this is W, Y, X, Z, and then this is the universal set that's out here. And then they should tell you then to go back and probably find all the different pieces. They're going to ask you to find X and Y and Z and W. Okay, so what you have to do from there is kind of the same thing. Start with what you have in the middle. Sorry, get up here. So just go back. They give you this one. So always go back and just draw this. So always go back and just draw this thing in and figure out from here. You've got the intersection of A and B that's in the middle right here. That's 17. You know that would go there. And this is almost one of those that I would almost make a list like this because they're going to ask for them here, but the easiest one to find is going to be 17 that's right off the bat. So I hate that to me, they should almost ask for that one first because that's the easiest one to find that's here. Okay. So they gave us then that A was 23. So if there's 23 total here, we'll do 23 minus 17 to figure out that there's 6 that's here, which would be the X. For B, there were 26 total here. So that's 26 minus 17. That would be 9. That would be here. And that was Z. Okay, and then W was everything that's on the outside. Well, if there's 26 that's here, says there's 41 that's not B. So it's not B, that's going to be, take out the B that's here, and that's everything else that's kind of back out over here with all these other pieces. So if we've got 41 that's not B, so basically we take this part out. We've got 6 in here that's A that's not part of B. So then you can do 41 minus 6 to figure out then that there would be 35 on the outside. And again, we got that from being that if there's 26 in here, which means there's 41 that's not in the circle of B. Well, if there's 6 that's here, then the other 35 have to be on the outside that's there. Okay, so there's one where they, again, kind of give you the parts and pieces of it. And you could probably still use the formula to go back and get some of those. But to me, that was one that, with what they gave for the Venn diagram on this one, you could almost just go back and use the Venn diagram to kind of pull through the pieces there. Okay, and then the last problem of the day. This is where we will go back to that handout that was here with this Venn diagram. And it's basically the same thing, just they get a little bit more creative on all the information that they're giving to you here. So we've got the number of A prime is 25, the number of B is 23, A prime union B prime is 35, and then A intersection B is 12. Okay, I'm gonna pull that back out of the way for a minute. Okay, so the intersection of A and B, you've got 12 right in the middle. So that's the first thing I would go through and do, and put up so you can see it there, is put a 12 right in the middle of A and B. Okay, the other thing that you can get is right here that there's 23 in B total. Well, if there's 12 that's in A and B and that's here, so we'll just do 23 minus 12, so that puts 11 that's here. Okay, and then here's where you have to start getting a little bit creative, kind of like it was on the last one. The number that's in A prime, the number that's not in A. So again, if you take out the circle of A that's here, it says it's 25. So there's 25 outside of circle A. You've got 11 that's here. So we'll do 25 minus 11. So that would put 14 that's here. Okay, and here's where they kind of use the counting principle to kind of, they gave you the counting principle, but didn't really give you the counting principle because you've got to use it, but we're also going to do it on the opposite on this one. That just like we did the number of A union B was a formula where we were using on that earlier one. You can also do the same thing with the primes. If you do the number of A prime union B prime, be the number of A prime plus the number of B prime minus the number of A prime with the intersection of B prime. So where they gave you that counting principle earlier that we did with all just the regular numbers, you can also do the same thing with primes. So then you can go back and plug in the information that you got here for this one. So the number of A union intersection primes was 35. They gave us that A prime was 25. Now we don't have B prime, so that's what we're looking for. Because then they gave us the A intersection, B intersection here. That's basically this part that's right here. So it's not in the intersection of A and B. So that's everything outside of A and B. So it's going to be the 14. Okay, so then we can go back and kind of solve through this one. So then we've got 35 would equal, if we do 25 minus 14, that's 11 plus x. So subtract 11 from both sides. So that means that 24 would equal to the number of b prime. Okay, now you may be saying, well, what does that do? Because now we've got the number that's in b prime. We're not trying to figure out what's in b prime. We're still trying to figure out what's here in the rest of a. Well, we know that the number that's a prime, or that's not in a, is 25. So we use that to kind of go back and get the 14 that was here for this part of it. That basically, to get this number, we've got 24 that's not in b prime. We know we've got 14 that's out here. So if we take out the a prime for this one, we've got everything here that's 24 that we're looking for. That's the b prime. That's everything in here. We've got 14 that's here. So the rest of what's not in b would have to be what's in here. So that means there would be 10. So again, the number that's not in b prime. So if this is b that's here, everything outside of b is 24. We've got the 14 that's here, which means that everything else then that's in the circle A here would have to be the leftovers. So if we know there's 24 total outside of B, and there's 14 that's here, we'll do 24 minus the 14 to figure out that there would be 10 that would be here. So going back and getting those answers in, so then number 1 would be 14. Then we get 10, 12, and then 11. So that one, they got a little creative. Again, with the counting principle, because they gave us one earlier with just A's and B's, but it works the same way with the A primes and the B primes when you go through those. Okay, so that one got a little bit more creative. You had to kind of work your way around some different parts and pieces on that one. And again, if you didn't realize that part of it, then you had to know that one to kind of get through it there. Okay. So I think that's a good stopping point for 8.2. A lot to do with Venn diagrams there. It's just playing around with them. If you haven't done a lot with Venn diagrams before, this is one you can kind of, slow down, take your time, and go through those and just play around with them. And it sometimes it just takes working through them a few times to kind of get the hang of what it is that they're asking for. So, okay. So that's all I've got for today. We'll come back in next time on Thursday. We'll pick up with section 3 and 4. Possibly finish up section 5. We'll see. Probably just do sections 3 and 4, and then we'll get 5 on Tuesday the next week. So, but if you don't have any other questions, then that's it for today. I'll post the notes and the videos on Blackboard here shortly once I can get everything uploaded there, and then we'll see y'all again Thursday. If you got any individual questions, if you want to hang around once everybody leaves, then you can hang around once everybody leaves, and we can ask some individual questions. But other than that, we will see y'all Thursday.
See you.